Right, this is a representation of how an isotropic an isotropic kite could face any wind using a net configuration and external tethering. So here, the upwind tether is longer than consecutive downwind pointed tethers, shortest at the end. So you've got an angle of attack of the overall net um, into the wind there like that. Now, obviously, it's not going to fly flat like this, so I've run a simulation showing how it might well advance given the wind, given lift on the certain points and some line drag. But further than that, it might be worth considering how densely you can pack this isotropic net in order that you might get more effects than just a lifting surface. So if that net was able to drive trolleys around this ground circle by having a lifter on each of the main points as we had in that little show just there. So if you had a lifter here, lifter on each of these nodes, and the vertices, if there was infill that drove this whole set clockwise, you'd need trolleys that shortened the tethers as they came round here, lengthened as they came up that way, but that could easily be set as a function of the radius of the distance of travel around the circle. So you could mechanically link that so it would happen automatically that this would rotate, drive around here, affect its own tethers, and then I guess you're hopefully looking for a bit of extra energy as it's throwing it round in order to generate. Now, assuming you can stack these, it might look a bit messy in its final setup. If I run this again, it might be tricky to stack them like that.